Graphs of logarithmic functions. We are given 4 graphs of logarithmic functions, and we are told to write the function form of each graph. Let's start 3 in from the left, the curve that goes through the point 3, 1. This is the curve y equals log base 3 of x. Now if you look at the graph just to the right of this, it is this same graph just shifted down 1 unit because it goes through the point 3, 0. How we show that symbolically is we write -1 after the parent function. So we'll write y equals log base 3 of x minus 1. Now going back to what we'll call the parent function, log base 3 of x. Let's look at the very first graph that we see. Notice it is the reflection of the parent function across the y-axis. Symbolically, the only thing we need to change is we write negative x in place of x. So the first graph has a function form y equals log base 3 of negative x. Now the remaining graph, the one that's second in from the left, is the reflection across the x-axis of the one we just looked at. How we show reflecting across the x-axis is we have a negative sign in front of the notation. So y equals negative log base 3 of negative x. Now let's look at domains of logarithmic functions. We know that for any logarithmic function, y equals log base b of x, the domain is x is positive. X is greater than 0. So the domain of the function that's given, we have to write x minus 3 is greater than 0. Therefore, the domain is x is greater than 3. Finally, let's graph a logarithmic function and its inverse. The function that's given is f of x equals the natural log of x plus 4. Natural log is log to the base e. Most calculators will have an ln, or natural log function. So we can make a table of values from -4 to 4 in the x's and just type in these numbers and get the corresponding y values. Now we can plot these ordered pairs and connect them with a smooth curve. And here we have our function, natural log of x plus 4. Notice the domain will be x is greater than -4, and the range is going to be all reals. There is an asymptote, a vertical asymptote at x equals -4. But let's follow the direction that says graph the function, the inverse of f inverse of x. So we can do that by either switching the x and y in the table and graphing those points and connecting them, or I like a graphical approach for finding the inverse. I graph the line y equals x, which is this blue linear function that passes through the origin and has a slope of 1. And then I find the reflection of the original function across this line. So my green curve here is the inverse of f of x. Now we'll answer some of these questions. The domain of the original function f, x is greater than -4. The range is all reals, and the asymptote of the original function is the vertical line x equals -4. Let's look at the domain of f inverse of x. Remembering that when we're talking inverses, we switch the range and domain, right? So the domain of f inverse will be all reals. The range of f inverse is y is greater than -4. The asymptote of f inverse is y equals -4.